Hey guys, welcome back to AlgoYogi. We're doing tree series right now. Our next problem in the list is trim a binary search tree. Let's go to the problem on LeetCode. Given the root of a binary search tree and the lowest and highest boundaries as low and high, trim the tree so that all its element lies in between low and high range. And then trimming the tree should not change the relative structure of the element. That will remain even if we were to basically delete a particular node because it was out of our range, and it can be proven that there is a unique answer. So return the root of the trimmed binary tree. Note that root may change depending on the given bounds, because the root might lie beyond bounds, but that doesn't mean all the values are basically needed to be trimmed. So that root will be taken by an appropriate values, which is basically the value in your mostly in your left subtree. So let's go to our notepad and see how we're going to approach it. So let's see the first example, which is 3 nodes. One is root and left child is 0 and right child is 2. Now they have given us the range low as 1 and high as 2. Now just imagine now you can tell this is inclusive, so the range is inclusive. So if you see which value is out of our range, so you guys can already tell 0 is out of our range because we can only include values 1 and 2 inclusive, so 0 is definitely not in that range. So how are we going to remove it? How are we going to trim it? Now there could have been a case where let's say let us keep it simple. We're going to start traversing our binary search tree. We go to the root, we see if my root is in the range. If it is, in this case it is. Now I'm going to start processing my left side, and I see the value is not in the range. If value is not in the range, then I'm basically going to return in this case I'm returning none. However, I was supposed to check both of its children, because maybe there was a case, not in this example, I can't see any more values other than decimal values. Like I could have kept here maybe 0.7, that is between 1 and 0. So you know the properties of binary search trees. I can't have any value that is greater than 1. So in this case, let's just imagine if I were to have 0.7 here, then I should have kept it, right? So right now in this example, I will return none. However, let's say if 0.7 was here, then this is a valid node that should be returned to this place. So basically I'll have a recursive function that will check if my root is out of range. If it is, then I'm gonna check if it was basically lower than my low range, then I would return basically the right child, because everything, if this is lower than my low range, then everything in this subtree will also be smaller because it holds the property of a binary search tree. Then I am not including this side. Then I will just simply return this, but not just return. I think I would run the recursive function on this subtree as well, because at the end of the day, I want to return a properly trimmed binary tree, given I am applying low and high range properly on that particular subtree as well, right? So let me show you guys like a better example to make things clear here. So let's say if I were to have a tree which is 1 and then 2 and then let's say 4, this side I would say like, let's say 3, and then here I would have, let's just say 1 over here and 0 over here and 2 over here. So I'm just trying to make it like a proper binary search tree that we are trying to run our algorithm on. And let's have our range low as let's say maybe 2, and high, let's just say maybe 4, right? All right, let's just say 3 maybe. Then let's start our approach here. Now I'm gonna go to my root and I'm gonna check if my value is in my range. It is. So just return the root, but run the recursive function on left and right as it is for checking. Okay, now I'm gonna call the function on my left subtree, the same recursive function which is trimbst. Now I will check again if this is in my range. 1 is not in my range, so then I'm gonna check if my 1 is lesser than my low, which it is. Then what I'll do is I will trim this entire part. Tell me if 1 is lower than my low, that means everything in the right of my 1 will also have to be trimmed, because it will be smaller than my low range. So I can't include that. Even I can't include 1. So that means I will return my right subtree and I will apply that recursive function on right subtree. All right, I think now you got the gist of it. Let's write down the solution. It's going to be very simple, and it will take basically big of n time complexity, because we are basically processing each node, and at least we are visiting each node once, and not in that case where we are trimming them, but at least in worst case we are visiting all the nodes and checking their values. They are lying between low and high. All right, let's switch the view and code up our solution. So as I said, if my root is none, that means I return none. What else? If my root.value is, let's say, lesser than my, because we are considering low and high as inclusive, so not gonna have like a strict equality check. We're not gonna have a equal to here. So if root.value is lower than low, that means I will return self.trimbst on my right subtree with the, so root.right. Even if it were to be none, that means it will return none, because we have this base case right over here. All right, so, and then we're going to provide the right range which is given to us. Now the same case is gonna be applied to right side. If my root.value is higher than my basically high range, that means I cannot consider any more values off to the right of that particular node, because they will be bigger than my high range and I don't want to include those. So I would rather just return none from there. So I will basically call it on my right subtree with the same range. So that will be root.left. Sorry, I meant left subtree. So root.left and the same range. What if my root is a valid value between my range low and high? That means I just have to process the left subtree and right subtree separately and then just return the root. So it would be basically root.left. Root.left would be basically the same on the left subtree. So right over here and this one goes for root dot right, and right over here, and then just return the root. Okay, return the root. Now let me zoom out and run our examples. It's a straightforward solution, and this is a typo. I didn't mean to write right over here, but hi. Oh my god. And that is because we did not change it over here, right? And root dot left goes left and right goes right, right? Because here I had to switch them, you know. All right, so this passes the examples, then all right, it's accepted. Have a pretty good time complexity. So now let's just write it down for our interviewer. Time complexity would be big of n, and the space complexity will be big of h, and worst case that would also be n. So space complexity would be big of h. That, let's just call it n. All right, let's go to AlgoYogi and mark this problem solved, and voila, see you guys in the next problem. Bye bye.